Good evening, students. So today we will discuss about correlation. So in general, the correlation means relationship between two or more variables. So the exact definition is correlation analysis deals with the association between two or more variables. Here we have types of correlation, positive and negative. Positive correlation is nothing but if one variable is increasing and the corresponding another variable is also increasing, that means both x and y are in the same direction, right? See this example for the positive correlation. Here the values of A are some increasing level, that means 10, 12, 15, 17, 20, and the corresponding B is also increasing, that means 12, 20, 22, 26, and 27. Therefore, here both A and B are in the same direction. Therefore, the given correlation is said to be positive. But in the negative correlation, see this example, if one variable is increasing and the another variable is decreasing, right? Therefore, the given correlation is said to be negative. Yes. So the next one is simple, partial, and multiple correlation. So simple correlation is nothing but we can take only two variable relationship. Yes. So the next one is multiple correlation. So multiple correlation is nothing but we can take more than two variable relationship, right? In the similar way, partial correlation means we can take more than two variable relationship excluding some other variable. Here we have one more type, that means a total correlation. Total correlation is nothing but all the facts are taken into an account. So the next one is linear and nonlinear. Suppose here you have to plot the x and y on the graph sheet. Suppose if you're getting the straight line means the given correlation is said to be linear, otherwise a non-linear correlation. So okay, next we have the methods of studying correlation. Basically, here we have two cases or two different methods of studying the correlation coefficient. The first one is a graphic method and another one is mathematical method. So in the graphic method, we have two cases, that is scatter diagram and scattergram method, and also simple graph or parallelogram. But in the mathematical method, here we have four cases. That means the Pearson's coefficient of correlation, then Spearman's correlation, and then coefficient of concurrent deviation, and also method of least square. So this is a scatter diagram to represent our positive correlation, negative correlation, and no correlation. So no correlation means there is no relationship. Yes, there is no relationship between the x and the y, right? Here we have to represent the data in the form of dotted values. Here dot diagram, the scatter diagram is also known as dot diagram. Yes. So the next one is simple graph. Yes, they will give some raw data, that means the data. Based on the data, here you have to draw the graph. With this, here you have to represent the relationship between the two variable. That means simple graph method. So the next one is Pearson's correlation coefficient. This is the example problem for the correlation coefficient, particularly Pearson's method. So already we know very well this is the general formula for the correlation coefficient. So this is x and y. Here you have to find the x square value, y square value, then x into y. Then you have to find the summation, that means total. Summation x, summation y, summation x square, summation y square, and summation x into y. With this, here you have to find x bar and y bar. Next, here you can find the r value. You can substitute all the values in the general formula of r. Finally, you can get the correlation. That means Pearson's correlation. That means R of x comma y is equal to 0.95. Suppose if having the plus 0.95 means the given correlation is said to be positive. Suppose if you having the negative values means negative correlation, right? Okay. So the next one is regression, Spearman's correlation or rank correlation. This is the notation for the rank correlation or rho, rho equal to 1 minus 6 into summation d square divided by n into n square minus 1. So where d means a deviation, rho means rank correlation, then n means number of paradox relation, right? So this is an example for the rank correlation or Spearman's correlation. So the next one is regression. So the exact definition of the regression is the measure of average relationship between two or more variables in terms of the original units of the data. So this is a general definition of the regression. So this is a general formula for the regression line x on y and y on x. Regression line x on y means x minus x bar equal to r into sigma x divided by sigma y into y minus y bar. Similarly, here y minus regression line y on x means y minus y bar equal to r into sigma y by sigma x into x minus x bar. So this is the general, simple example for the regression line x on y and y on x. Yes, I think this is enough for this correlation coefficient. So thank you students. Thank you for watching. Thank you very much.